In this video, we'll talk about the concept of conservation of energy, or the power supplied is equal to the power absorbed in any circuit. So here we have a voltage supply having a voltage around 10.02 volt and three elements in series. These are the three elements, number one, number two, and number three. So we want to measure the voltage across each element and the current that goes through this circuit, I, as you can see here in the circuit, and then we want to find what is the power that is supplied and what is the power that is absorbed, and make sure that the conservation of energy applies. So let's do the measurement. First, we will measure the voltage across each element. So we'll start with the one that's V1. So it's around 6.46. For element 2, it is around 2.14 volt. For the last element is equal to 1.42. So these are the three voltages. Now we want to measure the current that goes through this circuit. So again, we have to remove the connection of the supply to measure the current, and we need to do the connections, the proper connection of the current. So connect it here and select the current measurement. Now we are set to do the measurement of the current. So the current is around 6.48 milliamps. So the same current will go through all the three resistors, and the same current that is coming from the supply. So let's go back to our circuit here. So these are the measurement that we have. We have the voltage, we have the current 6.48 milliamps, and we have the three voltages of each element, 6.46, 2.14, and 1.42. Now let's see the energy calculations, the power that is absorbed and the power that is consumed here in this circuit. So when you see here the measurement, the calculations, sorry. So here, let's see the calculations. So the power that is absorbed, now the current enters the positive terminal, so this is be absorbed. And for the supply, the current leaves the positive, so here P is supplied. So we have these three elements, and when we measure them with the right polarity, we are getting plus minus, plus minus, plus minus. So the power that is absorbed in the three elements, you multiply the voltage, 6.46 times the current. Now, since this is the same current going through the other element, so it is 2.14 times 6.48, and finally, the last element, which has a voltage 1.42 times 6.48, so you have total of 64.93 milliwatt. Now for the power that is supplied, now the power supplied, since the current leaves the positive, we give it a negative sign. So the voltage is around 10.02 times 6.48, you get minus 64.93 milliwatt, or summation of the power in this circuit is equal to 0, or power absorbed is equal to power supplied. And this is always the case in any circuit.